I suppose the world of hydrokinetics is fairly new. We're like a very good fit, I think, especially in this country, as part of energy security, because you can generate locally. Like solar or wind, your generation is very local, but it's also very predictable.
This is The Energy Canvas, bringing energy solutions to life, with your host, Celtic Dynamics CEO, Dylan Walsh.
Hey, Dylan here today. We're looking at a part of the renewable energy that doesn't always get as much attention, but has huge potential: hydrokinetic energy. Unlike traditional hydropower, this is about generating electricity from free-flowing water without dams or major infrastructure. Joining me is Gary Brennan, CTO of GKinetic Energy, who's working on developing turbine systems that can generate clean, renewable energy from rivers and tidal flow. We'll talk about how the technology works, where it fits into the wider energy system, and what opportunities look like for Ireland and beyond. Gary, you're welcome to the Energy Canvas.
Thank you, Dylan. Great to be invited.
So to start us off, do you want to give us the quick story about hydrokinetic and what it does and everything like that? Yeah?
Yep, I will do. I suppose to differentiate it from traditional hydropower, which a lot of people do, they mix it up. It's generating energy from free flow of water. So there's no dams, like you said, there's no abstraction of water. So there are quite a few types. It works quite similar to wind power. So it's basically a range of different types of turbines which can generate electricity from the movement of water.
Okay. So I suppose in practical terms then, how would the turbine system work in terms of being installed or being actually put in a river then?
So our current model, what we've designed it's a floating model. I suppose the world of hydrokinetics is fairly new. So if you compare it to wind power, what you traditionally see is a wind turbine. It's got a vertical tower with three blades spinning, like with the horizontal axis. There have been loads of different types of designs tried out over decades. This has come out as the most efficient way. So because hydrokinetics is such a new field, there are lots of different types of devices. Some are vertical axis, some are horizontal axis, some are cross flow, and some are fixed to the bed of a river or into the sea. Our version is floating. So we started out as a tidal energy developer, so a technology developer. And working on a project, we were asked, could we generate power from the River Shannon in Limerick? So we're based in Limerick. And Limerick City Council had a project. They said, look, can you adapt your technology to work here? So we did. I suppose we started off kind of from a blank slate. We had our technology concept and then the conditions of the River Shannon. So we developed a unit which can float, stays on the surface of the water, which is where the fastest water is. And when the river dries out, it'll sit on the riverbed.
Okay.
So the idea of this is that we take advantage of the fastest flowing water on the surface all the time.
And I suppose in scale size, what scale was that prototype version or whatever then?
That particular one that went in Limerick, that was 6 meters wide, 6 meters long, projected about 2 meters under the water.
So what would you be expecting then from a unit of that size in terms of kilowatt power?
That one was a 12 kilowatt. So the way our system works, we've got a floating platform, we have a round, like fixed body under the water, and a vertical axis turbine either side.
Okay.
That one would power about 25 houses. So kilowatt installed, if you compare it to solar, it doesn't really make sense, because solar, obviously, you're only generating while the sun is shining or, while it's daylight. Whereas with hydrokinetics, it's in the river, it's flowing, it's producing nonstop all the time the river flows.
And I suppose with it being a surface model, it doesn't care so much if it's heavy rain or anything. It's very constant.
It's very constant, yeah.
That's interesting. So I suppose at the moment you're at a prototype scale. So what now do you need to get that to an actual feasible technology, or what are the stages you're looking at in terms of that?
With that 12 kilowatt unit, we decided it's built for tidal estuaries, big rivers or tidal estuaries. And one of the issues with that is that along with the planning permission, you need a foreshore license. So we realized this was going to complicate issues somewhat for our development. So we moved to a smaller unit, which would work in, I suppose we looked at the amount of sites that are available that we can produce electricity. We moved to a smaller version. So this is 2 meters long, 2 meters wide, just under a meter deep. So it can fit into those shallow rivers. And where we are now with it is, look, we have not fully commercial ready product, but we're very close to commercial ready. You know, we need a pilot deployment to run this for a year so we can gather data off that. So that's the stage we're at now. We're at the final stage. We're refining things now as opposed to designing, you know. We're adjusting parameters to get a little bit more efficiency. But really our biggest challenges at the moment are regulatory.
Okay.
More so than technology.
I suppose then, right, if we take it back to the current climate maybe at the moment in energy and stuff, like energy security is the hot topic, you know, how would this benefit maybe Ireland in terms of energy security?
It is a hot topic. 5 years ago, I was mentioning energy security. We learned about it in college. Like we learned about this, one of the main pillars of the renewable energy field. But when you talk to people a few years ago about energy security, it wasn't an issue. Now, after the invasion of Ukraine and Iran and the increase of storms, a lot of people are very aware of what energy security means. So what we see, we're like a very good fit, I think, especially in this country, as part of energy security, because you can generate locally. Like solar or wind, your generation is very local, but it's also very predictable. Solar, okay, it's fairly predictable. You'll get clouds, you can't predict everything, you know, in Ireland. The wind, again, you can't predict it. But with rivers and with rainfall, because of the way it works, like, you know, the rain falls in a field today. It has to seep down to the ground. It goes into the drain and works its way through, goes through a few water courses, ends up in the river. So you can fairly accurately predict 2 days ahead what the flow in the river will be. So because of this, for energy security, you can kind of know what your energy, you know, are we going to make that power off the turbine in 2 days' time? And because it's really suited to a decentralized system, this is again why we went from the larger unit to a smaller 3 kilowatt unit, because they're so adaptable, you know, it weighs 250 kilos. It'll work in a meter of water, which means it's suitable for an awful lot of sites.
So I suppose 250 kilos, that's the size of maybe like a 200 kilowatt boiler nowadays kind of range. You know, it's small enough you can fit it in a nice space, I'd say. And it doesn't take a lot of people to get it into the space realistically.
Yeah.
One thing that comes to mind, you know, is if it's still in prototype stages, you know, how reliable is the technology in terms of longevity, you know, because it's obviously in a body of water kind of thing.
Yep. And the answer to that is we can't give a clear answer until we have one running. This is where we are with it. Is like, okay, the technology works. We can make it more efficient. We could probably make it a lot more efficient. But even as it is now, we can produce electricity, energy at a price comparable to the grid per kilowatt. So for now, we're happy with that. So we're working to how do we get it into the river? And longevity, yeah, obviously we want this to be like the Land Rover of energy devices, you know. It's built to take abuse. We've done a lot of work on simplifying the technology so that there are less things to go wrong. Another part of it, I suppose, on longevity, we can't give it a direct answer, but we've done a lot of work. We've patented a system which allows our turbines to turn slower than the water that's going past them. So this has a lot of implications. We've got almost global patent on that because nobody else had managed to do it in hydrokinetics. Most people in hydrokinetics, they have a turbine which is turning maybe 4 to 5 times the speed of the water flowing past, which means, you know, it's very dangerous for anything that's in the water. But you've also got, and you can stop me if I don't want to get too techie with it, but like you've got torque loading, you know, you've got peaks, which means like a blade is going into power. So you get a burst of energy and then nothing and a burst of energy. So it's moving at really high speeds and then there's like huge jumps in power. So this all fatigues a machine, you know, it fatigues materials, bearings wear out. This is a huge part of what we've done is to increase the maintenance interval. You know, it makes you don't have to keep taking it out as often as possible. Parts don't wear down as often because you're reducing the RPM, you're reducing the stress on all the parts. So we expect 10 to 15 years lifespan, at least. The current model is made almost entirely of recycled marine grade aluminium. So it's a very durable material. Like, we're lending from the marine sector. So, aluminium boats have been in the sea for decades. And once it's the right grade and once it's built properly, they will last.
You kind of hinted at there in terms of energy security. This energy is a little bit more consistent than the current renewables out there. The install is a bit trickier. How do you see this playing long term? Let's say, okay, at the moment we're renewables, wind, solar. Yeah. What issue will this solve in terms of the grid? Maybe the duck curve or something like that. It'll balance it out a bit. Is that where you're kind of leaning more?
I kind of have to disagree a bit there. You said that the install might be a bit more difficult, but I don't think it is.
Well, in terms of planning, I mean,
Okay,
yeah.
Yeah, in terms of planning, it is now, but it's difficult now because it's a brand new technology.
Yeah.
So, like, when you talk to planning authorities, and in fairness, most of them are fairly open to it, where we have a feasibility for a pilot going on there. I had a pre-planning meeting there last week, and like, they're overwhelmingly going like, oh yeah, seems like a no-brainer. Looks cool. It was like, and like they said, it was like, look, it's a new thing. So we have to go on this journey with you. We all have to find out as we go along what happens here. Yeah, where we see it fitting into the energy, it's a baseload energy. You can fairly accurately predict, what the output will be in a couple of days' time. We don't say that we're going to produce all year round. So, we hit our peaks, obviously, November, December, January. The more rain, the more power we make. So, yeah, and it slows off during the summer. And like, we're fine with that, it actually works really well when you graph it with solar.
Solar, it's anti to solar, yeah, which is good.
Yeah. It's, and it works. Like, we have one, not a client yet, but like somebody who's is interested in the technology. He was onto us the last couple of years. He's waiting for us to be ready to install. He's in a special area conservation. So it means like the bar is a bit higher for acceptance to get in. And like, he's maxed out his solar. He can't install anymore. And it's not enough for him. And this is a regular thing that we come across. We've maxed out our solar. It's not enough for us. It doesn't give us the power when we need it, which is over the winter and at night. And this is where our system comes in. It goes 24/7. It peaks in the winter and then trails off as the water slows down during the summer. Some rivers run all year long. They're much better for power production.
I'm just thinking of use cases, but you probably have them with your pilot project. Is it more communities or a business thing, or what are you looking for your pilots or your initial installs?
A lot of our focus is on communities because of the scale of it. So what we're proposing with the smaller unit is modular. The idea is this is like, it'll fit whatever the width of the river is, we can work out how many we can put in. This also lends into, we try to size the size of the array or the station to the user. But obviously, compared to solar or to wind with hydrokinetics, you're tied to the river. You have to be close to the river. So what we're looking at is, and what we've put a proposal together, is for river energy communities. So you'll take a stretch of river, that that has good resource, has good flow on it. You will get a number of clients along that river, people who want to take part in the community. Then they all club together. They form, like an sustainable energy community. And then they're also pooling their money. So if you have environmental impact assessment, screening, a tour impact statement, this sort of work that has to be done, instead of doing one individual one for each one, you do one for the whole section. I've talked this through with people in the ecology division, National Parks and Wildlife. For them, they have to consider every application in context to other applications in the area. So if you actually do this as a community, you're making less work for them and you're spending less money on the outlay. So it's easier for them to process. It frees up resources. And then you're into this situation where you tie in stewardship of the river with the fact that you're generating your energy from the river. It's not just your energy source, it's your responsibility. That's kind of our ideal use case, is that you will have a stretch of river. And we're looking at that, like we're looking at a pilot site up in Cavan, and upstream of that site, there are several people. Some of them have reached out to us already. Some of them have already been on the sites and seen where they have a resource. And that's also ideal because we've already talked to the ecologists in the area. We've talked to the planners, and it's replicable.
And I suppose, is that you putting in an array rather than one device then is what you're talking about? What's the plan?
Yeah. So the plan for the smaller one is that we deploy an array.
Okay. Yeah.
So instead of you can put in one, you'll generate power from it. If you put a range of these across the river, you leave gaps in between them. Because hydrokinetics works from the speed of the water flowing, if you can make the water a little bit faster, you can make more power. So our proposal is that we will install in an array across the river. You leave spaces in between. That means there's enough space for fish, most importantly, for fish to travel up and down the river. Because of the slow turning speed of the turbines, it doesn't pose such an issue because the hydrofoil is moving slower than the water. So, for the fish, it's something is moving slower than it is. And this also allows river users like kayakers, supboard people, you can go up and down the river. So the idea is you deploy an array across the river. That way you just get an extra little bit of power. We don't want to damage the bed of the river. I know this, I'm kind of jumping from team to team, but it's all part of the whole. So you don't want to damage the bed of the river because this disturbs fish spawning.
Ecosystem and stuff.
Yeah. And increases turbidity. So what we're looking at the moment is a system where we would put a suspension cable across the river up high enough so that you can travel underneath it. But then all of the units would be suspended from, basically 2 suspension cables across, sort of like you're driving 2 piles on either side, one for the upstream and one for downstream. And all the turbines are suspended off these 2 cables.
Yeah.
So what this does is, for a start, for deployment, putting them in the river, you don't need to go into the river with a boat. So you don't need to disturb us. You're not putting in an anchor into the river or something that's going to disturb the bed. They can all be fixed onto the cables on the bank and then pushed out into place.
Yeah.
We tied this with a debris detection system, which can see if you've a tree. There's always things floating in the river. Branches, trees, rubbish, all sorts of things. So we're developing a system which will assess what's coming down the river. If it's something that's too big, it'll just lift the turbines up out of the rivers. It doesn't get stuck in them.
It's a good way, I suppose, to ease on that fatigue question. Because, let's say offshore wind or whatever, the fatigue is the big problem with them, Yeah. But I suppose if you're avoiding the main, I would imagine, problem in the river is stuff coming down the river you didn't expect. That would probably increase your fatigue life on them a good bit. You've got a pilot project of an array. You've got planning stuff solved. You've got your turbines in the water. Yeah. Okay. What is that community then expecting in terms of energy benefit, I suppose, or decarbonisation or any of that? That's probably the big question for, I suppose, an investor or something who's helping you with that pilot. Yeah.
What's the payback period and what energy can you get out of it?
Yeah.
So look, it's all site dependent. So we're looking at 1 unit in an optimal site will make about 18 megawatt hours a year. So you can scale this up. The more units you put in, obviously the more power you make, but we're also looking at ways of adapting the depth of the unit. So if you have a site which is regularly a meter deep, we can make our blades a couple of 100 mil longer, and then we make more power. And because of the way we've designed, the modular way we design and build the turbines, this is possible. So we can have a range of different size unit, different length of blades. So depending on the main body stays the same, but depending on the average depth of the river, you can get a little bit more power by putting a longer blade in.
So what are you working out your payback then on roughly, or your?
Currently, we're looking at about 3.5 years.
That's very good for a technology like that, like for early stages as well,
Yeah. And that's without grants like.
Like solar's only got into the 2-year range in the last year or two,
Yeah.
So, and that's with grants, So.
Yeah, this is without grants. This is straight up how much we can produce kilowatts for.
So I suppose, what are the things you're coming up against that are maybe stop getting you at the moment, or you're finding to be issues with bringing a new technology to life?
For us, it's test facilities. So, and lack of test facilities. So we, for a good while there, we were stuck in a catch-22 where if we want to install on a site, obviously we're going to have to go through environmental consenting. We're putting something into a river. Almost every river in Ireland is either in or upstream of an SAC. So that's unavoidable, There are some places where it's not relevant. Most places it is. And because it's a new type of technology, of course, people want assurances. But to get the information we needed to get permission to install, we would have need to have installed. And we need to have installed in that type of environment. So, and it was not possible to get a derogation to install somewhere to gather this information. So, for example, with the 12 kilowatt one, the one we installed in Limerick, temporarily installed in Limerick, we worked on a project with Queen's University Belfast in their tidal test centre in Strangford Narrows. So they've got a derogation from DAERA, the Environment Agency in Northern Ireland, which allows them to use the test site, even though it's in a special area of conservation. It allows them, it gives them a certain area where they can test tidal devices. So while we were testing there, we had underwater cameras on it constantly, all the time it was running. It only ran during the day so that you could have good visibility. We had a marine mammal observer who was basically sitting in the top floor of the Queen's Research Lab with binoculars and a red button, which would stop. If they seen a marine mammal, they would hit the button that it would stop. Based on that testing, we were the only tidal developer in the history of the site, in the 10 years that it was working, that DAERA moved to deploy and monitor without shutdown. So it was because of, again, the patented system with the slow-moving turbines. And because of that information, we were able to get planning permission for the project in Limerick with the larger device for an array of 3. And we went through full environmental consenting, Natura Impact Statement, Annex 4, Annex 12 species, the environmental impact screening. We were able to do that because we had the information from work with Queen's. With the smaller version, that test site isn't suitable. It's too big. The site is too rough. And there was nowhere else we could install to gather the information that would allow us to make the application to install. So we kept hitting this thing where we talk to fisheries. They look at it and they go, yeah, it doesn't look like it's going to cause a big problem, but we need reassurance on these factors. We can only gather the data by installing, and we couldn't install without gathering the data. So what's changed now is the RED 3, so it's the Renewable Energy Directive 3, which is transposed, which basically means it pushes regulatory authorities to accept renewable energy projects.
Yeah, it's advancements in energy technologies. Yeah.
So this is what's kind of allowing us to move forward with these first pilots. We're still going to be stuck there where you get somebody going, okay, so how do they work with salmonids? Mm-hmm. What's the behavior of salmon and trout around these devices? We can only get this information by installing in a river where there's salmon and trout. Mm-hmm. But we can't get into that river until we install. So we're still stuck in this catch-22. And this is the biggest blocker, is not being able to get a derogation to gather the data that will allow us to move forward.
What do you see as your next key milestone then to get it moving forward? Or is it to get a resolution around these derogations, or what do you see?
Yeah, getting the first ones in the water, gathering data. That's a huge milestone for us. So for a lot of people, because it'll de-risk things. And we think we're well on the way towards that now because of RED 3 coming in. We've seen a change in attitudes from people, regulatory authorities based on this. They're kind of, okay, it's kind of, I don't want to say surprising, but to see a directive being transposed and employed and for actually to make the difference that it was supposed to, it's quite refreshing.
These are small scale systems. Connecting them to the grid, have you any issue on that end as well?
Not really. We go through an inverter. We put in, it can be an island grid system. It goes into a battery. It's like any renewable energy technology,
It's the same. It's like solar. ESB come out and check it. They're happy. Yeah.
From what ESB have told us before, it's the last bit of kit that connects it. As long as your inverter is certified, you're fine. It's installed. You get a Recce installer and you use certified equipment, then that's all you need to do.
Where do you see the biggest opportunities for the technology then in the future?
Anywhere with rivers, really. We're not tying ourselves anywhere. We know it's a step-by-step process. We get into a non-SAC site. We gather our data. We move forward. We get into and this will be a step-by-step. We get into a slightly less protected site. And then, we work our way up to where we get an acceptance, where it's a proven technology. And then there is no specific market segment. If it's industry or domestic, it doesn't really matter to us.
We're kind of coming up to the end then. So this is one thing we do on every podcast. Just to wrap up, we ask you, do you have any question you would like to ask anyone in the industry? And someone from the last podcast has left you a question. Yeah. So is there any question you would like to ask in the industry in general that you would like to know an answer to?
It's kind of tied, I suppose, to the last question on the last podcast. When can we move to support the people who need to move to renewable energy the most, which is people in energy poverty? It's people who are in remote areas and, they've got bad infrastructure. We keep seeing regularly that there's lack of capacity on the grid. We see people who are running diesel generators because they can't get enough grid capacity. So, that's my question is, how do we help those people? It's all well and good going, okay, there's a grant for your EV charger. There's a grant for putting solar and there's a grant for your retrofit. But the reality is that the people who really need this most, they can't afford 8,000 this year to put the rest of it that goes along with the grant. They've got a boiler that they haven't serviced because they don't have money. And that's what's polluting. That's what's making it worse. They're not getting the benefit of it, and how do we help those people the most?
So how do we help the people who can't afford of their own course to actually do these projects? That's what you're really asking. Yeah? Okay. And then I suppose the last person left a question for you. How do we make sure that low carbon energy solutions are the most cost effective option for customers, which is kind of similar to yourself, so that they're the best choice for the climate and energy security is also the easiest choice for people to make?
I think it has to be through grants. It has to be through supports that, like that last person said, make it the easiest choice. Because a lot of people don't have time to think about this, They're busy lives and we've got a lot of stuff going on and, kid breaks his arm and then you've got something else. And it's like, there's enough going on in your head without having to try, okay, how do I fit into this energy mix? We need more supports for people and we need more sustainable energy hubs, which will explain to people what supports are best for them.
That's a good point. I suppose a lot of grants are in the easy to install space, I would say, or the well-known technologies. And it's the people who can't necessarily afford it probably need another way of supporting it as well. Okay, that's it, Gary, then. So thanks so much for joining us. It was really interesting to hear about that new hydrokinetic energy and how it's going for you. It was great to have you on.
Great to be here. Thanks, Dylan.
If you would like to find out more about what we covered in this episode, you'll find notes, links, and more in the description area of this podcast. Do remember to press follow for our show so you get the next episode automatically. Also, please do share with a friend who you think would find it interesting. Just tell them to search for The Energy Canvas with Celtic Dynamics on their podcast app. Our podcast today was produced by dustpod.io and brought to you by CelticDynamics.com. Until next time, thank you for listening.